welcome to Silicon Valley Buzz, where we investigate sizzling stories coming out of this, the most fertile spot on the planet for new ideas. And you know it's true. Silicon Valley sports tremendous concentrations of high-tech expertise, bright minds to find imaginative solutions to the problems that beset humankind at the start of the 21st century. The Valley is endlessly abuzz with new ideas, new concepts, and that's what this program is all about. New ideas that will change how we live, how our grandchildren live. I'm your host, Seth Shostak. Janet Wu is the producer. Bobby Chastain is our director. And tonight we're going to talk with Dr. Stephen Zornetzer. He's the Associate Center Director at the NASA Ames Research Center, one of the principal engines for innovation here in the South Bay. Steve, welcome to Silicon Valley Buzz.
Thank you, Seth. I'm delighted to be here.
Well, if you go inside the main gate of NASA Ames these days, you see some construction project, and this is not a new traditional research facility. It's kind of an odd-looking building. What is this?
We are building what will turn out to be the greenest, highest performing building in the federal government. It's called Sustainability Base. We named it Sustainability Base in honor of the 40th anniversary of the Apollo 11 astronauts that landed on Tranquility Base on the lunar surface. Our intention with Sustainability Base is to demonstrate here on planet Earth what NASA can do in the 21st century by bringing some of NASA's own technologies that we've developed for aerospace applications and embedding them in a building for the first time on planet Earth to increase the performance and the energy efficiency of this building.
Well, I think most people, when they think of NASA, of course, they have this sort of simple view that NASA is all about going into space. They don't know too much about the aviation activities in NASA and the many other activities. But I don't think that many of them would have thought, well, going green, environmental concerns, so that's not NASA. They launch these big rockets that burn up a lot of fuel in a short amount of time. Doesn't sound very green. Why are you doing this?
Well, you know, if you think about the Earth, it's our only habitat right now. And it is a closed-loop system. We are fully dependent on the resources of this planet in order for the human species and other species to survive. Much like if we were to create a habitat, a human habitat, on some other planetary surface in the future, we would have to depend on the local resources, or we would have to supply all of the life support systems necessary to support human life. We would like to demonstrate in Sustainability Base the ability of technology here in Silicon Valley and here at NASA Ames Research Center to demonstrate that a building can minimize its impact on our planet, maximize its energy efficiency without compromising habitability, without, in fact, promoting a very healthy and a wonderful environment to live in. That's our goal.
Well, now this building, I mean, I've been down there, I've seen the building, it's behind a fence, it's still under construction. This is not a tiny building. This is not like, you know, some sort of Quonset hut building that you might find in a rendering of a future colony on the moon or Mars. This is a big building. It can hold a couple of hundred people, right?
Yes, it'll hold about 210 people.
210. Are you actually going to put 210 people in there?
Yes.
Okay. And what are they going to be doing? Are they guinea pigs for the building?
Well, you know, they're going to be partners with the building. I don't call them guinea pigs, but I call them partners, because in order for the building to perform at its optimal level, there's going to be a dynamic partnership between the occupants of the building and the building's intelligent control system, which we at NASA have developed in various modules previously for aerospace applications. We're bringing those software modules that we developed at Ames back into this building to provide intelligent adaptive control for the building. It will be the most advanced control system of any building on the planet. The control system will actually be able to predict tomorrow's weather, predict the occupancy of various rooms in the building based on people's calendars, predict when the control system should turn on our geothermal wells, which provides the cooling system for the building, or when it should turn on the solar collectors for hot water for radiators if it's a cold day.
It sounds like it's not going to heat my office if I go for a 2-week vacation in the winter. But you talk about control. It almost sounds like a laptop, right? It has this control system, right? What sort of things are you going to control? This is to be environmentally friendly.
Yes.
You know, what are you going to control?
So the building is designed to have a combination of passive and active features, which working together will provide extremely high performance. So some of the I'll tell you about what it can control in a second. But some of the passive features of the building are very simple. Its location on planet Earth relative to the arc of the sun, to maximize the amount of solar flux that we get on the photovoltaic panels on the roof. Very simple idea, very passive. Didn't cost us a penny, but increases the energy efficiency. It optimizes the energy efficiency of the photovoltaics.
But you had the freedom to orient it any way
We
you
had the
want.
freedom to orient it, and that's just a design decision. It's very simple and it makes a lot of sense. The windows are all operable.
You mean you can open and close
We
them?
can open and close them. The occupants of the building have control over a lower tier of windows that they can open and close manually. An upper tier of these operable windows are all controlled by the computer. Similarly, we have active shading systems controlled by the computer. The lights are controlled by the computer. We will have an extensive wireless network of sensors throughout the building, informing the control system in real time about all of the environmental conditions of the building. The people who are occupying the building will have direct access to the control system by telling the computer, you know, it's a little too cold in my area today. That's information for the computer. The computer will actually, the control system, will actually learn from its own performance over time. So it will improve its ability to control the building over time.
Okay, so I hear you talking about temperature control,
Temperature.
heating a building, cooling a building. Those are expensive things to do in terms of the energy. So if you can somehow make that smarter, that sounds like a good deal. What about other aspects? What about, you know, water use? I mean, that's always a big concern.
This building, a second NASA technology that we've developed at NASA Ames for the International Space Station, is a water purification system that will be operating in the building. It's the first deployment of this water purification system on planet Earth, even though it's been operating on the International Space Station for some time. So this is a forward osmosis-based system that will take hygiene water from showers and sinks in the building, take that water, purify it to a certain extent. We could actually purify it to the point where the occupants of the building could drink it, but we don't need to do that, and we're not going to do that. But we're going to clean up that water and use it for toilet and urinal flushings in the building, because there's no need to use potable water for those purposes. In addition to that, all of the landscaping in the building was very specifically designed to minimize water use. So we're using natural plants, we're using bioswales, which is a contoured form of landscaping that maximizes the surface area of the landscaping, so that when we do enter the rainy season, and if we get heavy rains, we get maximum absorption of that local water in the surrounding campus of the building, rather than have that water run off into the bay, which we'd like to minimize. In addition to that, any irrigation that we do need for that landscaping is recycled water from another portion of NASA Ames that used to go into the bay. Now we're conserving that water, not putting it into the bay, and using it as irrigation.
Well, we've been talking about this. I think it would be interesting to actually see the building. And thanks to the hardworking people here at the station,
Great.
we have some video of what this building looks like. And maybe you can tell us what we're looking at to the extent that you need to, because I think that we got a tour from somebody who's connected
Sure.
with the project. So if we can roll the B-roll on the building.
Some of the features, the energy-saving features of the building, the outside there's aluminum louvers that protect the south-facing windows from the direct sun. They allow the light to come through for daylighting, but they prevent the sun from getting on the windows directly and reduces the solar heat gain in the space. The upper row of windows for the building, those are operable windows. Those are computer controlled. It's a mixed mode design, so we will actually have, for most of the year, We'll have the ability to open the windows, get fresh air in the space without using any mechanical equipment. For large portions of the year, we're hoping that we can just ventilate the space using the operable windows. The major cooling for the building is provided by the radiant panels. These are aluminum panels that comprise about 80% of the space inside the building. On the back side of these panels are copper pipes that chilled water flows through. The water cools the entire panel surface. The cooler air is heavier, so it sinks down and makes the people feel cooler. The doors are made with a material called plyboo. Most of the wood in the building is FSC certified, so it's a sustainably harvested wood. The windows are really high performance. It's got some pretty tremendous properties. It's fairly transparent, so a lot of the visible light is allowed to come in, but yet the solar heat gain is really, really low, so it doesn't pick up a lot of heat from the sun. Another energy-saving feature is the solar hot water system. The domestic hot water is provided by solar collectors on the roof, and that provides all the hot water that we need for the building. These are light shelves. Light coming in from the north side comes in that upper row of windows, bounces off the top of the light shelf, which is a very reflective surface, and then bounces back off the radiant panels, and it's able to get further into the building, provide more light for the daylighting for the space. We sited the building in order to try and maintain as many of the heritage trees on the site as we could, and we worked around those trees during construction. They're beautiful old trees, they provide a really nice view, and they provide shade. It's not only about saving electricity, it's also about saving water. Potable water is becoming a really valuable resource, and we use about 90% less potable water than a comparable building of this size. We do that through the selection of the plants that we use on the site, California native plants, drought-resistant planting, drip irrigation. We capture the water from the sinks and the showers, the gray water. We take it to a treatment plant that we are working on right now. It was designed by a NASA scientist, and that water is going to be treated and then put back in the building for flushing toilets and urinals.
It looks like a lot of windows. Does everybody have windows? Are there any interior offices?
There are very few interior offices. All the interior offices have windows and have glass walls to maximize the amount of natural lighting that we use. We did a lot of modeling and simulation with our computers at Ames prior to the design of the building. And our modeling for this particular building indicates that the overhead lights, which consume a significant amount of electricity over the course of a year in a conventional building, the overhead lights will have to be turned on the equivalent of 40 days per year. The rest of the time, the building has sufficient natural lighting that people shouldn't need any additional overhead lighting. In addition to that, the second floor of both wings of the building have skylights down the central spine of the building, which brings in another incredible amount of natural light. It's really a beautiful space.
Those automated upper windows, do they have screens, or do they let the flies in?
Actually, they have screens.
Oh, good. I'm glad to hear that. Now, once again, the reason that this is being done is that there's really an executive order that pertains to government buildings, that by 2030, they've all got to be able to do what this building can do.
Yes, that's right. That's correct. So this building is 20 years ahead of its time, and it demonstrates the fact that today, 2011, we can achieve that standard right now.
And so if this works out, I mean, what's the time period between you decide, okay, we've got this nailed down? I mean, I'm sure there are going to be some hiccups here.
Yes.
They're going to, I mean, I have to say, every time I see those sinks where you have to put your hand under them to get them to work, I think, no. I mean, it's like the low-flow shower heads, which I immediately take into my garage and drill out all the holes. I mean, you know, so you'll have to shake this down for a couple of years, and then do you expect that this design will be replicated elsewhere at other government sites?
You know, this design was specifically chosen to optimize the building's performance for this location on planet Earth. In Buffalo, New York, this design would not work very well. But anywhere else on the planet where there's a similar climate, the design could work extremely well.
Now, this is called sustainability base, and
Yes.
that's somewhat of a gesture toward the Apollo program. But on the other hand, these technologies? To what extent are they the result of NASA's efforts in going into space?
Yes. Well, as I mentioned before, the two technologies, NASA technologies, which we're directly embedding into this building, are a number of software modules that we're combining in a unique way. They've never been combined before. But these are optimization algorithms, these are data mining algorithms, these are prognostic algorithms to be able to predict the healthy and remaining useful life of mechanical and electrical equipment, pumps and other things, that we've developed for aerospace applications, because you don't want a critical failure of any of these systems when you're flying. So we'd like to be able to predict failure before it occurs. So we're combining all of these modules in a unique way to use it as a control system for this building. Once we've perfected and demonstrated this control system, we would love to license this to the commercial sector and let them broadcast it and use it for all of the new buildings that will be built in the future.
Well, that's a point, actually, because, of course, NASA's not the only organization here in the Silicon Valley that's building green buildings, right?
Sure,
I mean,
right.
Cisco is building some, I don't know, I think it's PayPal. There's some of the other high-tech companies are building green buildings. So what are you bringing to the table?
Well, we're bringing these unique NASA technologies, which none of those other buildings have at this point. This is the only place on planet Earth where you'll be able to find these technologies in a building on the planet.
Can you give me an example, Steve, of a technology that was developed for use in space that's in this building? I mean, what about the recycling of the water?
Mm-hmm.
Is it?
Yeah, well, the water purification system that is currently being used by 6 astronauts 24/7 on the International Space Station, that water purification system was designed and developed by Ames scientists and engineers. It is now flying, and it's what enables the International Space Station, in fact, to be inhabited for a long period of time, because water is very expensive to transport from low Earth orbit at $10,000 a pound. So if we had to supply fresh water to the International Space Station, my guess is we wouldn't have astronauts up there.
Yeah, I think water is 64 pounds per cubic foot or something like that.
So
that sounds pretty expensive to put it up in this space. But how do you do that? I mean, when I think of purifying water, I think of, well, I would just, have a whole lot of sand and pour it in at the top, and what comes out the bottom is clean water.
So for the space station application, you wanted to minimize the mass of the system and minimize the energy consumption of this system, because it's a closed loop system. You have to generate your own energy, and to bring the mass up, the upload costs of that, if we were to use sand, would have been prohibitively expensive. So we developed a system here that optimized the functionality for water purification, but minimized energy requirements and mass requirements of the system. So it's basically a polymer system using a series of polymer films and using the simple principle of forward osmosis to separate large molecular structures and ions from, there's a picture of it there, from the water, separate them out using forward osmosis and osmotic gradients, and doing a few other tricks with that water system, with that water, to make it acceptable for human consumption.
And if you could build those things really inexpensively, I can imagine that every building in the valley might use those and then take the water out of it and at least irrigate the front yard with it.
Yeah, or use it for toilet and urinal flushing. Yeah. I mean, there's a very simple way of saving a tremendous amount of potable water.
One thing that, of course, is fairly obvious would be energy generation. I take it there are solar cells on the roof here.
Yes. And
what percentage of the energy requirement of the building is supplied by those guys, and how do you store it at night?
Okay, so let's talk about the energy, because that's an interesting story. So there are two sources of energy generation for the building. One is the photovoltaic array on the roof, which will provide about 30 to 40% of the total daily energy requirements of the building. In addition to that, we have another NASA technology that we became a Silicon Valley startup and a company, Bloom Energy. Bloom Energy is providing the first installation on planet Earth of their next generation hydrogen fuel cell. That will provide probably 150% of what the energy requirements of the building will be. The combination of those two things results in a situation where we have much more energy being produced on the site than being consumed on the site. All of that additional energy goes into the Ames grid and offsets other other buildings that have energy demands.
Sounds like some sort of Prius building. You know, during the daytime, you use the solar cells on the roof, the voltaic cells on the roof, and then at night you use the fuel cells, the bloom boxes.
Exactly.
Those are fuel cells, so they have, you know, they require some fuel. What is it, natural gas?
We're going to start using natural gas. My goal over the next year or two is to obtain a methane source, which would be a natural product of biogas and other things, landfills. We have lots of landfills in Sunnyvale and Mountain View. I would love to be able to capture some of that methane in a partnership with the local cities and use that as the energy source for the fuel cells, in which case then the fuel cells become zero net carbon footprint, which is a goal.
We talked about how some of these technologies came back to Earth. Do any of them go back into space? Or any of these technologies going to be useful even in orbit, let alone a moon base or something like that?
Well, you know, we're working with Johnson Space Center, and they are providing some resources for us to do long-term testing of these polymer films that we're using in the water purification system. We're going to get a much better understanding of the lifespan, the biofouling, and other kinds of problems that could develop in these systems over time, especially if they're used in the future for a human habitat elsewhere, either on the moon or on Mars. We're going to have a good baseline database from this building that will inform NASA in the future. So this is a two-way street. I think it benefits NASA and it also benefits humankind here on Earth.
It's hard to believe that it's a perfect prototype for a base on the moon. I don't think you'd want to open the windows too often, but at least the technologies can go back into space.
But the water purification system is what I was referring to.
The water purification, for sure.
Yeah.
And the other thing is that this building, I mean, how long is it going to be before this building is sort of shaken down and you can say, look, we're going to put the 220 people in it and we're going to try and license the technologies or whatever. We're going to build buildings like this elsewhere, maybe on the Ames property or some other place at a more or less similar latitude. What's the time scale?
Well, the building will be completed and turned over to the federal government in August, so just another month and a half from now. Occupancy will begin in early fall. I believe we'll have enough data and through this shakedown period, about a year or so after occupancy, I think we'll have all systems up and running and fine-tuned. And at that point, I think this building will have achieved all of the promises that we've been talking about, all the goals we've been talking about.
From an economic standpoint, if I'm building office space here in the South Bay, and you know, a year or two from now, you say, look, we got it working, we know what you have to do. Could I afford to do it?
Oh, yes. Our back-of-the-envelope calculation is that the premium that we paid up front on all of these energy-saving and energy-generating devices was about 6% of the total cost of the project. We expect with reduced energy costs, utility costs, and reduced maintenance costs, we will get that money paid back. The return on investment will be 9 years for the American taxpayer. So after 9 years, for the rest of the useful lifespan of the building, which may be another 40 years, the energy costs combined with the lower maintenance and overhead costs for the building will pay a handsome return for that 6% investment. It'll be a net positive gain for the American taxpayer in the money they save versus the upfront money that it costs to build in these features.
It sounds like nobody would think of doing otherwise than
we would hope
these
so.
Technologies in.
Yeah.
This building won an award, didn't it? I mean, I didn't see any trophy on the front lawn, but...
It'll be in the lobby of the building. Yes, last year, 2010, the General Services Administration, which operates and owns virtually all the federal property in the United States, selected this building, Sustainability Base, for the Greenest Building of the Year award within the federal government.
Is there any competition?
Was
that a big award? Tell me about the competition. I'd like to know what Ames is competing against here.
We were competing against virtually all of the new federal facilities that are being built across the country that applied for similar recognition.
To what do you attribute to winning? Just
well, I
cleverer
think
people?
The highest performance, I mean, I think this building represents something that's imaginative, that goes beyond the ordinary, that has novel technologies embedded in it, and has the promise of delivering something much more back to the American people and the world than any conventional approach to a high-performance building.
Yeah, Steve, years ago, in fact, I think it was 1985, I was living in Europe, and I went to an expo, a technology expo, and they had there something called the House of the Future. The House of the Future. And, you know, it was a fairly small thing, actually. It looked like a private dwelling, but it looked like something the Jetsons would live in, or something like Futurama, I don't know. But it was completely opposite to the intention of this building, because it really used more energy. Everything was automated. There were displays everywhere. There was everything was air-conditioned, heated. You know, the idea there was better living through more electricity. Right? More energy use, more water, more of everything made for a better life. And that's been true for humanity for, you know, maybe the last 200,000 years. So this is really quite a switch. You're nonplussed. Okay, it's quite a switch. But I guess what I'm really asking is, suppose many of the things that NASA develops have long-term consequences, like power sats, for example. Could we ever, you know, solve our energy problem by putting big arrays of solar cells in orbit, for example, and just beam the electricity down to Earth? If you could do that, or if you could get hot fusion to work, maybe electricity would become really, really cheap. If you could desalinate water cheaply, maybe water's no longer an issue. How sure are you that 20 years from now people will look back on this and say, well, that was the wrong approach. We actually want to use more electricity?
You know, we do live in a closed loop system. The planet is a closed loop system. We have finite resources. If we could tap into infinite resources, if we could harness all of the energy of the sun, sure, that would solve many of our problems. But we still have water issues. We still have materials issues. We're consuming, you know, our natural resources and raw materials at a much faster rate than they're being replaced, and in some cases they're not being replaced at all. Rare earth metals and other things. So it's not just the energy from renewable resources that's the issue. It's all of the other resources that are not renewable, that the built environment and we as occupants of this planet are consuming at a very fast rate. I think we need to take a different look at that behavior.
Well, Steve, thank you very much for being with us today and talking to us about this very intriguing building.
Well, thanks, Seth. I appreciate being here, and I love the opportunity to talk about a great new building.
I'm Seth Shostak for Silicon Valley Buzz. I hope you'll join us next month for another intriguing story from the Center of Innovation on this planet. Good evening.